So I want to make an update on the T-Magic E6 VGen after owning it for about a month. Total runtime is about 5 hours or 10 to 12 battery packs. So I did manage to break a few parts, or to be precise, I gave it to someone who never driven an RC car before and they hit a tree, so not all the broken parts are the car's fault. But yeah, I want to talk about the setup and what I think about it after owning it for that long. So let's talk about the electronics first, because these do not come with your car. You have to supply your own. The ESC I have is Hobbywing XR8 Plus 150 amp censored, and as you can see, it's very tightly fitted underneath the plastic shroud, and there's barely any gap on the sides or in the front or in the back between the ESC and the shroud. This shroud is more of a cosmetic feature, so you can actually take it off if you want to put in a Max 6 or any kind of 6 scale, 5th scale ESC. I see a lot of people running no shroud, and it's definitely okay. It's just attaches via 4 screws here, which is kind of a pain every time you want to take out the ESC or plug in the program card to the fan port, which is like inside of here. The solder, the motor connections, I would definitely have to redo them, but I got this used here. It only costed me $140 for the ESC plus motor, so definitely it was a good deal. Also, most people run Hobbywing Max 8, which is very slightly smaller than this ESC, so it'll be a better, not as tight of a fit in here. So no complaints really, or no other comments on the ESC placement. For the motor, I'm running a 4274 sized Tenshock 2150 kV. The full name is X812l. So these motors used to be popular 4 to 5 years back in 1/8 scale buggy electric competitions, but I don't think these are produced anymore. But an interesting fact is that these motors have one of the highest watt rating. It's 3500 watts, and it's the highest out there versus the Hobbywing or any Castle motors ever produced of the same size. But I have no idea what this means. I have no idea how to measure that, and just a fun fact. So for this servo, I'm running a 46 kilogram JX coreless. It was only about $45. So the real rating is nowhere near 46 kilograms. It's about 27 to 30. That's what I got from other YouTube reviews. But even then, for the price, it's okay. The speed is 0.12 seconds over 60 degrees, so it's quite average, but I don't really notice any difference versus my other Power HD servos, because I run mostly on grass, so it's hard to notice whether it's faster or slower. Also, regarding the motor does get a little hot on 6S, but I am running a 13-tooth pinion, which also comes stock in with the car. And most people don't run 2200 kV, or in this case 2150 on 6S. So I have another fan on the way, a WTF fan from RC Mart. So hopefully it will help with the temperatures. I don't have a temperature gun, but my ESC or motor never cut out on me so far. I do try to take breaks, maybe like every 7 to 8 minutes, but I'm definitely not going easy on it. So far I have no issues with the electronics that I have, and the total cost is only about $200 for the motor, ESC, servo, the eBay special heatsink and fan. The fan actually, the solder points came off once, so it was just really poor solder job. So you might want to check the solder points if you do get one of these eBay special $10 heatsink plus fan combos. So a few more details on the electronic setup. The motor mount is one of the best I've seen so far. You can see that it has the gear mesh count. Gear mesh, I guess, support. You can see that there are marks here. These are the pinion tooth count, like 12, 14. Right now I'm using a 13, so my lower level mark is set between 12 and 14. And how I set it is quite simple. You can see there is a spur gear and a pinion. So all I have to do is set it between 12 and 14 and then rock the spur gear until you know, it has just a little bit of movement before it hits the pinion gear. So on this side, the spur gear is fully covered. There's a plastic piece that is combined with the wire holder. But on this side, there are holes. Oops. I guess they are for venting and also so that any debris, you know, have a hole to come out, I guess. The motor mount also acts as a heatsink. The whole setup, like this whole setup here and even here, they get quite hot when I run the car. So it probably helps with heat dissipation. So like I mentioned in my first video, this car has two receiver boxes, one in the front here, which is bigger and can house bigger receivers, and one in the small here that is completely waterproof. So depending on what you use, you are also supplied with the Y split cable. That means normally it goes from the receiver box over there to the servo over here, where you can plug in your servo and the LED lights. But in my case, I'm running the front receiver box. So my Y split cable actually is in this receiver box. So I run the servo under the battery strap, which is also a very neat setup. So you don't see any of my servo or ESC cables right now because they're routed throughout the chassis. One sec, here. You can see that this is the servo wire going from here to here. There's a Y split here, and that Y split is routed through the other battery on this side because the chassis is almost symmetrical here. So it's wired through here and over there, and ESC is also, oh never mind, ESC is actually plugged into here because they cannot share one channel with the servo. But anyway, it's a neat setup that where the wiring you know, can be almost completely hidden. The sensor wire can also be hidden underneath the I guess there's this plate, I don't even know what to call it, under this. There's just a plastic piece, and it definitely can be hidden too, but you know, I just haven't gotten into it yet. So the wiring is, you know, you have a lot of options. Wiring and motor mount and, you know, just the electronics related things are just you know, top notch on this car. So one cool thing about the truck is that it's really symmetrical. That includes the arms, lower arms, upper arms, the camber links, the dog bones, even the drive shafts here, and even the hubs as well. So what I have for spares is they sell lower arms and upper arms, two of each in a set that cost only 15 bucks. And the hubs, they sell for 10 bucks, and that includes two of them. So for 25 bucks, you could have spares that will last you a long time. The same applies for even the cups, diff cups. They're all the same, whether it's in a center drive shaft or the side shafts. So the spares would also last you a very long time. Another cool thing is that not only the drivetrain parts are symmetrical, but also the gearboxes themselves are exactly the same front and back. So that's really cool. And even the shock towers are exactly the same front and back. All the cutouts, basically if you have one shock tower as spare, you could use it front and back, and that is basically half the car. You know, you could apply the same concept. So while we talk about the replacements and spares, I noticed that the draft shafts and all the diff cups are really basically still new. There's basically no wear on them. And I've seen pictures where they compare the diffs, like the actual diff case with the ring and sun gears. And these have the same diff in size as the Sen Reaper. Actually, it's even a little bit bigger, which is crazy because Sen Reaper is a big size, 1/7 scale or almost 1/6 scale. And these have the same or even slightly larger diffs. So you should have no problems with the drivetrains. So what you see here is my own modified servo horn. And this right here is the stock one. And you can see that I stripped the teeth on here. And before I even installed it, I already noticed that the teeth were not really cut deep. They were very, slight cuts that barely grabbed onto the servo. I thought it was a special design, but I had my doubts, and within about 3 throttle pulls, it stripped on me. And this is basically the only part of the car that I did not like as stock. And the weird part is that this horn looks simple, but there is this spacing here, which is really weird. You have to make any servo you buy to be exactly the same. Otherwise, it will rub on your servo and you'll scratch it like this. And this screw here, I also had to shorten it. Otherwise, it will rub on this plastic cap that goes on here like this, which you can see right here. So it's not a big deal. You can definitely shave this down, but I decided not to. And even if you do lose one, you can probably 3D print one really fast or make like a carbon plate cutout for here. So not a big deal, but a little bit disappointing. So now onto the most and also least exciting part of the video, broken parts. So what I have here is the chassis, diff housing screws, one of the hubs, one shock rod end, the alloy servo horn that I've talked about, 13-tooth pinion gear, but this is not a stock one. This is some cheap Chinese set of 5 for like $4. The front bulkhead and the front upper hinge pin mount. So starting with the chassis, you can see that it cracked right where the front is. So the way it works is that this is where the whole front end is sandwiched in between, and this part, I guess, is a weak point when you have frontal impacts. And this happened when one of my friends, who has never driven an RC car before, hit a tree or clipped a curb. I wasn't sure exactly how it happened, but when I turned around, I saw that the car was veering to one side. You can see it's cracked to this side. So an interesting thing is that this part is cracked right where the supporting mount, the alloy supporting piece, is attached to, exactly this shape. So that alloy front piece might not be, the solution. I'll probably try to CNC or make my own support piece that goes all the way from here to here, because this part of the chassis is really thick, as you can see right here. It's really thick. So the part that I was worried about is the thickness of the chassis right here. That did not cause any issues whatsoever. In fact, you don't even see any scratches on the underside of the chassis. It looks perfect. So maybe it can even be reused if I fix this part somehow. Alright, so the bulkhead broke right here. That's where it touches to the bottom of the chassis, like this. So this was a weird breakage because the bumper, the, basically everything else except for the chassis and the bulkhead and the hinge pin mount were basically unscathed or unscathed. Yeah, I don't know how to spell that. And weird thing is that you can see it cracked right here. This is the upper hinge pin mount. And even on the side that is not broken, you can see that there is this same, I guess, stretch in the material. And I also have the brand new one right here. You can also see that where the holes are, you have this marks, the stretch marks. So it's a weak point in the material. I'm thinking Team Magic is not drilling this right, or maybe they don't think this is an issue, but it's definitely, could be improved right here. All right, so next are the hubs. The hubs broke right here. And this is also a design issue, what it seems like to me, because you can see that there are cutouts right here like this. And I don't think they serve any purpose. These ears or the holes don't serve any purpose, but this is where my hub broke, exactly where the concave part is. On both sides, this side and this side, exactly where the concave thin part is. So if they filled this with material, I'm thinking the hub would have survived the impact. But this is, I think, my own fault. But again, it could be the remnants of my friend crashing it somewhere. But basically, I'm not sure how I broke the hub. So in the same first crash that broke the chassis and the front bulkhead, I bent all of my screws in the front diff housing. So these are the M3.5 screws that are used to attach the diff housing to the chassis and also attach the bulkheads to the chassis. It's a weird size that is not really common. Usually they're either M3 or M4. So you would have, you're very likely to have trouble finding these. And what I did is order a bulk of 30 pieces, M3.5 by 30 millimeters from AliExpress. But these cost about $8 from Team Magic, and they come in a pack of 6. So definitely not, I guess, not a good design. Or I don't know why they went with this. Maybe to sell more screws. But I saw some people designing, or I guess modding their diff housings to take M4 screws. So you could probably just do that. I heard that you just need to tap the diff housing and then just use this. Use the M4 screws. So I don't think it's a big deal. Alright, so next important part that I think I'll be trying to solve on my own is the shock rod ends. So what happens with the car is that the car has too much droop, and what that means is that the car has too much downward travel of the arms like this, and the only thing that keeps the arms in place right now are the rod ends of the shock and the top lips of the hubs. So if they travel too much, your top lip will stress right here and here, and your shock rod ends will pull out of the lower arm. So this is the exact rear left rod end that I pulled out of the arm. And the same thing I started noticing is happening in the front of the car, where the rod end is stretching. So what I used is the replacements from Hongnor, and these are Hongnor X3 rod ends for the shock, and they're a perfect replacement, except they use 5.8 ball cups, 5.8 millimeters, which is fine. I'm not sure why Team Magic went with 6.8 when all of the other parts of the car, such as camber links right here, they're using this right here. They're using 5.8 millimeter bolt cups too. So I'm not sure why Team Magic decided to go with 6.8 right here. Anyways, these are kind of cheap. You can definitely mold your own. But what I'm thinking of doing is making some limiting straps. They go from here to here, and that will help with the droop. So instead of your hubs and your rod ends limiting the travel and eventually cracking or breaking, you would have nylon straps holding the arms together. I mean, the arms from drooping too much. Another thing is that the skid plates, both rear and front, they have these arms, these ears that, you know, you're supposed to set droop with. So on the aluminum arms, you have droop screws right here on the lower arms, and that's where a screw goes through and it touches on the ears of the skid plate. And that's how you set whether, you know, you want your car to have more travel or less travel, suspension travel. So on here, you have a gap between the ear and the lower arm. So to prevent that, I put a rubber piece that is about 2 millimeter tall, so that the lower arm just touch the skid plate before they reach their limit. But I think it's temporary. I'm definitely working on the straps that I think would help with the limiting the suspension travel. So on the front, you cannot do the strap going from the top to bottom cap, because the body is right here, so it will definitely rub on the body. So what I'm thinking of doing is using this diff housing screws right here to the lower shock, so it'll be kind of on the side and hidden. So the length you would need is 115 millimeters for of limit, but if you use these screws, you should need 110. So I'll be making my own out of some old nylon belts that I have, and we'll see how they work. Otherwise, the last broken part is the LED light. It ripped out of the bumper right here. But that is way too small of an issue, so not really important. Okay, so last thing is the body. So these skid plates work amazing. You can see there is only a little bit of damage to them. In fact, very little. Did I just say very little twice? I added the flex tape on the back, on the underside of it. And you can see this is where the shock caps are hitting the body. And I added about double layers of the tape, and they're still going through it. So I either need to raise the body more or add more tape. But raising the body more, it just kind of looks weird to me, so I'd prefer to either drive more carefully or just sacrifice the body. And this part, I don't know why I added it, but this here, I think it's touching the battery connectors. And in the back, you're fine. You don't really need this, but I just added because the area is flat and it's easy to tape it. Lastly, your spoiler will rub on your body here and here, but it's also a minor issue. Body definitely feels and held up great. So no complaints, all is good. So lastly are the tires. They feel great, they look great, but they balloon a lot. And you can see that there's basically no wear on them after 5 hours of use. And well, I run it on the grass, so definitely the wear is less than on asphalt. But I just wish they didn't balloon that much. And you cannot use the fishing line trick to strap your tires, because you can see the thread has no straight lines. For example, it's straight here and then suddenly there is a piece here, and then it's straight here. I mean, there is a straight like hole indentation here, but then there is a piece here. So you probably cannot do anything with them, but the tires are not coming unglued. There are no cracks or rips, and they definitely look great. They're very large. This is my hand. They're probably just short of X Max size, and I put them next to 3.8 Super Swampers by Proline, and these actually are slightly taller. So that is definitely one of the tallest tires on 8th scale I've ever seen. Yeah, otherwise the truck looks great, works great. The weaknesses are definitely not big issues. The only thing that really T-Magic should do better is think about the droop and maybe improve the plastic quality on certain parts and maybe design of the hubs. Otherwise, it's running great. I'll be putting in a better fan, straps, like I said, maybe a bigger pinion tooth